In today's lesson, we're going to explore angle pairs, and we're going to start with two coplanar angles that have a common side, a common vertex, and no common interior points, and those are known as adjacent angles. Adjacent angles, we got to have a common side, so let's let that be our common side. Common vertex, and no common interior point. So that would be a pair of adjacent angles. There are all types of different pairs that are adjacent angles, but there's one example. Okay, two angles whose sides are opposite rays are called vertical angles. Vertical angles, so opposite rays. So here's a pair of opposite rays. Here's a pair of opposite rays. So 1 and 2, angles 1 and 2 would be vertical angles. Angles 3 and 4 would be vertical angles. And I'll just go ahead and tell you this. You won't really need to know it for a little while, but vertical angles are congruent. There's a theorem that tells you that, and you'll use it many, many times. So what we know here is that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Okay? A linear pair, that's two words. Sorry, I wrote too large. A linear pair is a pair of adjacent angles whose non-common sides are opposite rays. The angles of a linear pair form a straight angle. So here's what a linear pair looks like. They're adjacent angles, so we know they have a common side, but the non-common sides, which are these two, are opposite rays. And then there's a common side, so it might be there or it could be anywhere, but that's a linear pair, and we know that they form a straight angle. Okay, two angles whose measures have a sum of 90 degrees are complementary. Wow. Hang on just a minute. Sorry about that. Two angles whose measures have a sum of 90 degrees are complementary angles. And therefore we say that each one is the complement of the other. If we have two angles whose measures have a sum of 180 degrees, those are called supplementary angles. And just like above, we say that each angle is the supplement of the other. Okay, so let's look at some examples. Solve for x here. Okay, so how are we going to do that? Oh, I know. Look, we have a right angle right here, right? We know that a right angle is 90 degrees in measure. Okay, so therefore, I'm going to draw what I have here. Look at this in red. That's a linear pair, right? That's a linear pair, and I know that each angle in a linear pair is the supplement to the other because they make up a straight angle, so I know that this also is a 90-degree angle. Therefore, I'm going to write this equation that 7x minus 4 plus 9x minus 2. I just changed this around to be 9x minus 2. I don't know. I just like to put my x's first. And I know that the sum of those two is 90 degrees. So I got 16x minus 6 equals 90. 16x is 96. Therefore, x has to be 6, right? And that's what it says, is to solve for x, not to find the angle measure. I could find each of those angle measures, right? By plugging 6 in for x here. 42 minus 4, that would be 38 degrees, which means this one here would have to be 52 degrees. Because they got to add up to 90 degrees. All right, and now we have a postulate. This is a postulate you will use many, many, many times in your proof. The linear pair postulate says that if two angles form a linear pair, then they are supplementary. So we got some examples. All right, clearly we got a linear pair here, right? They share a side, and then the non-shared side are opposite rays. So what do we know? We know they're supplementary because we just learned that. So we know that 7x minus 16 plus 6x minus 12 equals 180. And we don't really have any instructions as to what we're doing here, but I'm going to assume that we're solving for x. So let's just do that. So let's see, 13x minus 28 is 180. Add 28 to both sides. 13x is 208. Therefore, x is going to be 16. And you guys, when you are working these problems, it's okay if you use your calculator to make it go by more quickly, but please be advised that for problems like this, we typically don't use our calculator. You should be able to do that, not necessarily in your head, but somewhere on your paper. We don't need a calculator for small calculations. Okay, and now we got some practice problems for you. I'll start off with the first one here because it looks a little different. We have this angle here. This angle here is 295. What we need is to know how big this angle here is, right? Well, how can we figure that out? Oh, because I know that there are 360 degrees in a circle. So this little blue angle that I originally drew inside here must be 360 minus 295 degrees. And of course, that is 565 degrees, right? So this, let me just draw that a little bit better. So this blue angle here, 65 degrees. Okay, so now what do I know? I know that the sum of these two, 24 plus x minus 1, has to be 65 degrees. That's the angle addition postulate, right? Angle addition postulate, hope you're studying those. So 23 plus x equals 65. So x is 65 minus 23, which I believe is 42. So x is 42, which means this angle right here is 41. Okay. I'm going to let you pause here and do the rest of these practice exercises and check back in, and I will have a brief explanation and the answers for you. Okay, so here we are back at this diagram, and we're trying to decide if each one of these statements is true or false. 1 and 5. 1 and 5. So here and here. Are those angles adjacent angles? Sure they are, because they share a common side and they have no interior points that are common. All right, number 2, 3 and 5. Are those vertical angles? Well, no. Here's angle 3 and here's angle 5. So both their sides are not made up of two pairs of opposite angles. So those are not vertical angles. They're not congruent. Number 3, angles 3 and 4, are they complementary? Let me get my mess out of the way. 3 and 4. Here's 3, here's 4. No, those are a linear pair. That's a linear pair, right? 3 and 4. So they are not complementary. They would be supplementary. So I'll make myself a note there. Those are actually supplementary. And then how about angles 1 and 2? 1 and 2. Here's 1 and here's 2. And I can see that the two of them together make up a right angle, so no, they're not supplementary, they're complementary. So all those are false except for the first one. Please make yourself a note over here in your margin if we need to talk about this some more in class. All right, name an angle or angles in the diagram described by the following. Number 1 says we're looking for an angle that's supplementary to AOD. Well, I'm going to look for one that's a linear pair, right? The other angle in that linear pair, and that would be angle AOB, right? Supplementary, so angle AOB. Number 2, I want something that is adjacent and congruent to AOE. AOE. Okay, well that's a right angle, so I know its measure is 90 degrees. And I need another angle that's adjacent to it, so it's going to be that one. And I'm going to call it either angle COE, or you could call it angle EOC. It doesn't matter which way you name it as long as you got the O in the middle. And next, number 3, supplementary to EOA. EOA, that's this right angle right here. So that's going to be the same angle, right? Supplementary is going to be the angle that is the other part of the linear pair. So that's going to be angle EOC or COE, whichever way you like it. Number 4, complementary to EOD. Okay, here's EOD. Okay, and since this is a right angle, I also know that this is a right angle, so the angle that's complementary to EOD is angle COD. That would mean it's 30 degrees in there. And finally, I want a pair of vertical angles. Hopefully those are pretty plain to see. There's a pair of opposite rays. There's a pair of opposite rays. So those make up our set of vertical angles. We got AOB and angle COD there. All right, and finally, in the diagram, GH bisects FGI, find the measures of all angles. Well, first we had to use what we know about segment bisectors that tells us these two angles have the same measure, solve for X, and then we just used substitution to get the measure of FGI. Then we know that HGI has the same measure because a set of angle bisector divides an angle into congruent angles, so we get 30 degrees for that. And then finally, by the angle addition postulate, we know that the measure of angle FGI is 30 plus 30, which is 60 degrees. And that concludes our lesson, and we will see you next time.